Okay, question one, it says a particle P moves with constant acceleration. When you see the phrase constant acceleration, it means suvat and F equals ma. Okay. So at time t, it's moving with velocity 4I, so that's going to be RU. Find the velocity when P is equal to find the velocity when time is equal to 2 seconds. Now, what you don't do is like what I've seen in the you lot do in previous tests is convert everything into speed and all the scalar things. Okay, you work with the vectors. So constant acceleration, it means suvat. So what I've done here is I've just listed all the things that we do know. So we know the A, U, and T. We want to work out V. So that's going to be V equals U plus AT. So I did that and I got that. Now, the example would say if you leave it in column form, that and the questions in I's and J's, that's okay as well. But here I've converted it into I's and J's. So that's the velocity after 2 seconds. And part B, at t equals 0, the position vector of P relative to the fixed origin is that. So that's our starting point. That's where it's going to start from. Find the position vector of P relative to O at time t seconds. So I needed something with a t, so I used S equals ut plus a half at squared, using t as 3, and I got that 21 and minus 13.5, right? So then I said to myself, well, that is that vector from 1, 1 to where I've written P there. So I want the position vector. Now, position vector is just like coordinates. It starts from O. So I just want to OP basically. So I just added on that 1, 1, and I got that. Right, so that was question one. Question two is a pulleys question. And there's a lot of information that you've got to take in, and you just got to pick out the bits that you want. Now, a lot of it is repeated. You'll see it in every single question, now not just for police question, but for any question, but they've got to put it in to cover themselves, right? So, the line of greatest slope and inextensible, all that. So what I did for what they want is equation of motion. So I put all the forces in. Usually in these questions, the particle that's hanging down, when you release the system, that's the one that kind of goes towards the ground. But in this question, it's different. It actually the one on the slope actually starts to move down, and the one that's hanging actually moves up. So that's why I did my acceleration in that way. You got the reaction, the tension, and obviously the friction is going to be opposing the motion. So I've done it in that direction. And they want write the equation of motion for A. Right. So first of all, I just like I said, I picked out the important information. Mu is equal to 1/6. And I just did a little triangle like I usually do with the tan. Okay, and as before, like I've always said, you do not need to know what alpha is. You just want to know what the sine and the cos and the tan of alpha is, because that's what you're going to use. You're not going to use alpha. So let's go back to the question. Write down the equation of motion for A. So using F equals ma, so the driving force is the actual parallel component of the weight. Take away the tension, take away the friction. So, and they don't want you to do anything with it, so you just leave it like that. So you'll get your 2 marks for that. Part B, show that the acceleration of A is 1/10 g, and this is 7 marks. So obviously, the marks should tell you how much work you need to put in. So this is going to be quite involved. So part B, what I did, I started off by resolving perpendicular. Now I haven't written that. Normally I write that in. And the reason they ask you to work out what in part A, the equation of motion, because you're going to need that. So you're going to need a substitution for T and a substitution for F. So I started off by working out R because I'm going to need R to work out F. So F is equal to mu R. I multiplied by mu and I got that. So I got my F out of the way. Now, where was I going to get my T? Well, I was going to get my tension from particle B that was hanging, right? So that's hanging. So there are not many forces acting on that. So I just did a quick equation of motion for that. MA is equal to T, which is the driving force. And the weight this time is the resistive force. So I got my T in terms of M and G and A. So what I did, I just substituted all of those in there, simplified it, and cancelled by M, divided. So every single term had an M in it. Remember, you can't do that unless it's got every single term has to have an M in it. So I did that, and I just took the A to the other side, and then I divided by 4, and then I cancelled it down. And then you got A is equal to 1/10 G. Sketch the velocity time graph for part C, which is worth 2 marks. And that's just going to be a straight line with that constant gradient because it's constant acceleration. So velocity time graph is going to be a straight line, okay? And in reality, so where it says explaining your answer, there's constant acceleration. Well, that's what you really need. You get 1 mark for each thing. So constant acceleration, so it's a constant gradient. The gradient's going to stay the same. D, state the string is not light. How would it affect your working out to part B? Well, if it's not light, the tensions, the actual weight of the actual string is going to come into effect. So that means you're going to have 2 different tensions, okay? Because the tension on the slope is supported. That's good. The tension there is going to be less than the tension of the string that's hanging. You don't have to go into that much detail. You can just say the tensions in the 2 equations are going to be different, or the tensions in the string, the vertical string and the string on the slope are going to be different. All right, so that was question 2. Question 3 is a ladder question, and you got your usual information, and then part A, show that mu is less than a half cot theta. So first thing I did was put in all the forces, right? So they do a basic diagram, and it's up to you to put the forces in. Okay, so don't expect them to put the forces in, right? So because that's part of the marks of the question. So I've got that, and I resolve vertically. Vertically is just the mg and ra, so they're going to be equal. This thing's in equilibrium. Horizontally, F is equal to that reaction against RB, and the friction, well, F equals mu RA. All right, so you start off with them 3 things. 9 times out of 10, you do that. All right, there's been 1 or 2 questions where you have to start off by taking moments, but 9 times out of 10, you do vertically, horizontally, and friction. So you get them out of the way and they're ready. You might not need everything there, right? But the chances are you're going to. So it's good to kind of get them out of the way. So whenever you need, you can pick off whatever you want. And then I took moments about A, and I got that. I'll leave that. We've done that many times. So I'll let you decide for that. I cancelled A from both sides. So There, what I've done was the mg was the same as the ra. Now, normally you substitute in mg like in the previous question for the reaction, but here I wanted the same on both sides. So the mg I replaced it with ra, and the rb I replaced with f, right? Because then I can replace the f with mu RA. I'll have RA on both sides, which I can cancel like I've done there. And then I cancel the RA. So I got cos theta equal to 2 mu sine theta. And because we want the cot, so what I did, I divided through by sine. So cot theta is equal to 2 mu. And I divided through by 2, so mu is equal to a half cot theta. And at equilibrium, the f is greater than or equal to mu r. So I've said, so you can just state that. All right, it's a little bit confusing when you the f and the mu r, but for equilibrium, mu has to be greater than a half cot theta. So that was part A done for 5 marks. And for part B, horizontal force of magnitude kmg, where k is a constant, is now applied to the beam at A. The force acts in the direction which is perpendicular to the wall and towards the wall. And now they've given some values of tan theta and mu, so it's not symbols anymore. So we got some more values, and we have to work out the value of k. So what did I do? Because the situation has changed, I didn't rely on that first thing, because the reactions are going to change, things are going to change. So you draw a fresh diagram, which took me a few seconds, and then I make sure you get the kmg in the right is going towards the wall. Now this beam is the force is applied towards the wall, so the beam wants to actually move towards the wall, so the friction is going to be opposing it. Remember, friction always opposes the force. So I did my diagram like that. So looks like I resolved horizontally there, all right, and then I worked out the friction. Now we know what mu is, and we know what RA is from the previous. Remember, RA and mg are the only two vertical forces. So that hasn't changed, but the only difference is we know what mu is. So it's F equals a half mg. So I got that done. And then I went back to my resolve, when I took moments. Now, because of the kmg, when we took moments about the A, that's not going to change, because we're taking moments about the kmg doesn't come into it. So that same equation applies. So I got an expression for RB as well. So what I'm going to do is, so what I've done there, because we know what tan theta is, so we know what cot theta, tan theta is 5/4, cot theta is 4/5. So I substituted that in there, and I got what RB is. So I got my thing for F, and I got my thing for RB. Now I can substitute it into that equation that I got right at the top. And I got 2/5 mg plus a half mg equals 9/10 mg. Right, so k is equal to 9/10. Right, so that was question 3. This one, the usual information. The only difference is the acceleration due to gravity is modeled as having a magnitude of 10 this time. So watch out for that. They've even made it written it bold, so you don't use 9.8. Most of the time it's going to be 9. If they don't mention it, it's going to be 9.8, but they want us to use 10. Looks like, I think in questions like this, the 10 usually cancels. They wanted to cancel to make it simpler in the working out. What do we want to do? We want to work out the time taken for the stone to travel from O to A. So I resolve vertically using suvat. Remember, it's gravity, so constant acceleration, so we can use suvat. I'm taking upwards as positive, and u is going to be equal to 65 sine alpha. And the thing is, we know what tan alpha is, so we know what sine alpha is. So I got my u. That my u isn't my speed; it's my vertical component, vertical velocity. Okay, a is equal to -10 because I'm taking upwards as positive, and we want to work out what t is. So I put everything into s equals ut plus a half at squared, rearranged it to get a quadratic. You get a positive answer and a negative answer. Ignore the negative answer, and you get t is equal to 7 seconds. Right. Part B, find the speed of the stone at the instant when it hits the ground. So speed, remember, is the magnitude of the horizontal and vertical velocities. Same with forces, same with acceleration, same with displacement, right? When you got distance and speed and so on. So if they say speed, at some point you're going to have to do a Pythagoras calculation. So what did I do? Vertically, I had enough information to work out the velocity, which, if you note, it's negative 45. It came out because I used the t from part A. Why is it negative? Well, we're taking upwards as positive. When it was going upwards, it was positive, and this time it's going downwards. But we're going to work at speed, so the negative isn't going to, it's not a big deal. So that was vertically. Horizontally, remember, horizontally, the velocity stays constant because there's no acceleration horizontally. So I said v is equal to 65 cos alpha. Cos alpha was 12 over 13, which came to 60. And you've probably guessed by now we're going to do a Pythagoras calculation to work out the speed at that point. The limitation question, one limitation one limitation ignores air resistance. They write that because everyone starts to write air resistance, so they've actually mentioned that. So if you write air resistance, so you're not going to get any marks because they've already stated that. So what have I written? Yeah, there's approximation of G is used because we're using 10 when it's supposed to be 9.8 or 9.81. Other things you could have written is the spin of the ball, the dimensions of the ball, but that's got more to do with air resistance. So in this case, you know, if we used a more accurate value of G, that would have been better. Right, so question 5. So this one is to do with variable acceleration, and you've given that formula, and we want to work out the acceleration. So for acceleration, what we need to do from velocity to acceleration, we need to differentiate. So I said A is equal to dv by dt, and you get that. They just want it in terms of t, that they haven't given us any numbers, so that's that. Right, if they'd given us some numbers at say 4 seconds or something, we'd have to substitute that, and the magnitude of acceleration, we would have had to do Pythagoras obviously again. B, find the value of t at the instant when p is moving in the direction of 1 minus, or 1i minus 1j. Now, that's going to involve not the acceleration, but the velocity. Remember, direction is dictated by the velocity. You work out anything to do with direction is the velocity vector, not displacement, not acceleration, the velocity. So you wanted to move there. Now that, I've done a little diagram there. That is going to be 1 to the right and 1 down. Now you've already got the minus there. So basically it's kind of like 45 degrees below the horizontal, and in that case, for this case, they're going to be equal because you already got the minus. So you don't have to worry about that. So to get that equal, to get it in that direction, you just need them to be equal. The coefficients of I and j. So I got that. Now that was a bit tricky to solve. So I squared both sides, right? And don't forget to square the 3 and the 2, all right, not just the t's. Took it over to one side, equated it to 0, factorized it. Now t is equal to 0, which is at the beginning, at the origin. That's not very helpful. Or t is equal to 9 over 4. All right, so that's the time when it's moving in that direction. And then moving on, at time t seconds, t is greater than 0, obviously. The position vector of p relative to the fixed origin are meters. Right, when t is equal to 1, r is equal to minus j. Now they give you that, and the reason they give you that is you're going to go from velocity to displacement. You're going to integrate, and when you integrate, you get a constant, and when you get a constant, you have to work it out. So that little bit of information, t is equal to 1, r is equal to minus j, is to help us work out it's to work out the constant. So what am I going to do? I'm going to integrate the velocity vector, and you get that, just standard integration, plus c, right? You don't need to write a separate c and so d or c1, c2 for i's and j's, even though we're integrating it. So just write a c, and I'll show you how to handle that. So when t is equal to 1, r is equal to minus j. So I put in minus j for r, and I substituted in 1 for the t, and I got that. So can you see that you got minus 1j on the left hand side of the equals and minus 1j on the right hand side, so they're balanced. We just need to get rid of that or cancel out that 2i. So that means c is equal to minus 2i. Then I collected all those like terms, and I made it into a like a equation in t. And so that was that. Still no values, you just want the expression. D, it says find the distance of p from the origin at the instant when p is moving with the speed of that. Again, speed, that should tell you something to do with Pythagoras. So what did I do here? I got the components of the velocity, and I squared them and made it equal to 10 squared, which was 100. I rearranged it to make it equal to 0, like a quadratic, and I got t is equal to 4, or a negative answer, of course, which I ignored. And then I put that back into the displacement vector that I'd worked out earlier, and I got that 14i minus 16j. And we want the distance. So distance is the magnitude of the displacement. So I just did another Pythagoras, and I got that. All right, the exact value. Okay, I think that's the end. Yep. Okay, hope that was useful. All right, cheers. Bye.